so continuing on, our other algebraic method, the last one that we do, is referred to as case analysis. When we're talking about case analysis, the first steps are basically always the same. We're going to rearrange the inequality so that 0 is on the right-hand side, so we get everything on the one side. We find the roots by factoring or using the quadratic formula. That's always the same. Now, here's where it gets interesting. If x squared is positive, so that's the key. When we put everything on the one side, we need to make sure we have a positive x squared. When x squared is positive, we're going to have two possibilities. Either we're going to say it's going to be greater than 0 for the function, or it's going to be less than 0. If the function is greater than 0, then we're going to have both factors are positive, which we call plus plus, or both factors are negative, which we call minus minus. I'm just going to get rid of that dash just so it's less confusing. If it is less than 0, then we're going to have the opposite case. We're going to have plus minus or minus plus. We need to create two number lines, and we're going to try the different cases separately. So, if we use the same quadratic, we already know what the solution is because we've already done it twice before, but we're going to take it and we're going to say that it says that it is less than 0. So I'm going to say that case 1 is plus minus and case 2 is minus plus. We already know what the x-intercepts are because we've already done this. We're going to create a number line. And we're going to say that the lower point on the number line is at -6. The higher point is 4. Over here, the lower point is -6, and the higher point is 4. Now, when it says plus minus, what it means is plus on the left-hand side is the lower x-intercept is going to increase. Minus is saying that the bigger x-intercept is going to decrease. And any possible solution region is always going to be where the two overlap. If I take a look at my second possibility, then I'm going to have the one on the left is going to decrease because it says minus plus. The one on the right is going to increase. And here we see that in case 2, they never overlap. So there's no possible solution region for this one. So on the left-hand side, the solution region is going to be, when it's between them, or -6 is less than or equal to x, which is less than or equal to 4. There is no possibility on the right-hand side, which means that there's our solution. Okay, so for examples 4, 5, and 6 here, we're just practicing the different possibilities. So we're taking a look at our graphing method like we had before, and we're going to start by isolating everything on one side of the equation. X squared minus 4x minus 10 is greater than 0. I'm going to graph it on my calculator and find the x-intercepts. And in this case, when I graph it on my calculator, it's going to look something like this. And I'm going to state the points of those intercepts, where one is going to be at approximately -1.742, and the other one is going to be, and 0, and the other one's going to be at 5.742 and 0. Now remember, these are rounded, these aren't the exact values, but for what we're doing right now, that's okay. So, when it says that this is greater than 0, well, when is the function bigger than 0? Here and here. So I can just say that it's going to be when x is either less than negative 1.742 or when x is greater than 5.742. For example 5, if I'm using my algebraic method, then it says that I can either use roots and test point or I can use sign analysis. For this one, I'm going to do the roots and test point. So I'm going to start by, same as always, isolating everything on one side of the inequality. I'm going to move that 7x over, I'm going to move that 4 over. And I'm going to say that what I'm dealing with is 2x squared minus 7x minus 4 is less than or equal to 0. I can use a quadratic formula or I can use a factoring to solve for what the intercepts are going to be, and the intercepts are going to be at negative 1 over 2 and at 4. Now I'm going to draw out my chart. Where I have 3 possibilities: when it's less than 1, when it's in between, or when it's greater than the bigger one. I'm going to state my solution regions. I'm going to state my test points. I leave room for verifying, and then I'm going to state on the bottom what the solutions are. So my first region is going to be when x is less than or equal to negative 1 over 2. The middle region, when negative 1 over 2 is less than or equal to x, which is less than or equal to 4, or when x is greater than or equal to 4. I'm going to pick test points that work. For the first one, I'm going to pick negative 1. For the middle, I'm going to pick 0. And for the top, I'm going to pick 5. Just remember, I can't pick a point that is actually included. I couldn't pick 4, and I couldn't pick negative 1 over 2. All right, so now I'm going to substitute it in to see if it works. 2 bracket negative 1 squared is less than 7 bracket negative 1 plus 4. Negative 1 squared is just going to be 1, so that's just going to wind up being 2 is less than or equal to negative 7 plus 4. 2 is less than or equal to negative 3. That is false. In the middle region, 2 times 0 squared is less than or equal to 7 times 0 plus 4. 0 is less than or equal to 7 times 0 is just 0, so 4, that is true. On the top side, 2 times 5 squared is less than or equal to 7 times 5 plus 4. 2 times 25 is less than or equal to 35 plus 4. 50 is less than or equal to 39. That is also false. Which means that the solution region has to be where it is true, which means there's my solution. Negative 1 over 2 is less than or equal to x, which is less than or equal to 4. If I asked you to put the solution on a number line, you're just going to draw your number line, have the negative 1 over 2, have the 4, and because it says equal to, draw solid dots on both of them, and then shade in between the region. Those are 2 ways that I could represent the solution. All right. Case analysis for example 6. Step 1, always the same. Move everything to one side of the inequality. So I'm going to say that 3x squared minus 7x minus 6 is greater than 0. I'm going to use one of my algebraic methods to solve for what the x-intercepts are. And I'm going to say that x is equal to negative 2 over 3, or x is equal to 3. I have 2 cases. Case 1, because it is greater than it's going to be positive, positive. Case 2 is going to be negative, negative. Draw my number line. And I'm going to have my two intercepts, negative 2 over 3 and 3. And in case 1, positive, positive means that I'm going to have an open circle because it doesn't include the equal to, and it's going to follow along this way. I'm going to have an open circle, and it's going to follow along this way. And they match up when they're above 3. In the second case, open circle, the lower one goes to left, open circle, bigger one goes to left, and they match up in this region. On the left-hand side, I can say that it's going to be when x is greater than 3. And on the other side, I'm going to say that x is less than negative 2 over 3. If I want to put this on a number line, I can say that my final solution, if this is negative 2 over 3 and this is positive 3, is going to be in here and in there. Just make sure you leave that open circle to represent that it can't actually include the points.